Here's sample test 1, problem number 7. Place kicker must kick a football from a point 36 meters away from the goal, and the ball must clear the crossbar, which is 3 meters high. When kicked, the ball leaves the ground with a speed of 20 meters per second at an angle of 53 degrees to the horizontal. By how much does the ball clear or fall short of clearing the crossbar? Alright, so this is a two-dimensional motion problem. We're going to kick a football. And we're going to launch it with a 53-degree angle with an initial velocity of 20 meters per second. And it's going to go through some kind of trajectory, and the hope is that it's going to pass through the crossbar, so it'll be high enough to pass over this distance. So we need to find out what the displacement is, delta y2 is, or delta y, when it reaches the crossbar, knowing that our x displacement at that same moment will be equal to 36 meters. So it's really simultaneous motion. The time is the same for both, and we have kinematics going on from both in the x direction and the y direction separately, and they're both happening at the same time. We're interested in the initial velocities for both the x and the y motion. Our initial velocity in the x direction is going to be equal to our initial velocity times the cosine of our launch angle, which is going to be 20 times the cosine of 53 degrees, and that is equal to 12 meters per second. And our initial launch velocity for the y direction is going to be v naught sine theta, which is 20 sine 53 degrees, which will be 16 meters per second. So those are our initial velocities. We can use the x motion to find our time. We know that the displacement in the x direction is going to be equal to our initial velocity times time plus 1/2 acceleration in the x direction times time squared. But we have no acceleration in the x direction. It's unaccelerated in that direction. There's no gravity in the x direction. So this is strictly equal to 12 meters per second times time. Our time is the same in both directions. So our time is going to equal our displacement divided by our initial velocity in the x direction. 36 meters divided by 12 meters per second is 3 seconds. So if we're the coach, we want to make sure we run the clock down to 3 seconds or less before we call our last timeout, so that this is the last play of the game. Alright, so it's 3 seconds to the goal. How high is the ball at that moment? That's going to be delta y. That's going to be equal to the initial velocity in the y direction times time plus 1/2 acceleration in the y direction times time squared, which is going to equal 16 times t plus 1/2 times a negative 9.8. Since the y direction is going positive in the up direction, our acceleration would be a negative 9.8 times time squared. So it's going to be 16 times 3 seconds minus 4.9 times 3 seconds squared. And this is equal to 3.9 meters. Since 3.9 meters is greater than 3 meters, the goal clears the crossbar. Does the ball approach downward or upward when it crosses the crossbar? Well, we can look at the final velocity in the y direction, and that final velocity will equal to our initial velocity plus acceleration times time, and that would be equal to 16 plus a negative 9.8 times 3 seconds. That's going to be a negative 29.4 plus 16, which would be a negative 13.4 meters per second. So the fact that our final velocity in the y direction is negative means that the ball was on its way down. So, with a successful field goal, does Auburn beat Alabama? Of course. Auburn beats Alabama. No. Alabama beats Auburn because the field goal is wide right. So Alabama beats Auburn unless somebody's in the end zone and catches the ball and runs it back. But we're not going to talk about that. So we'll just leave it there. One of the teams will win.